Okay, so hello everybody. Very nice to be here this afternoon. I'm going to show you a presentation on closed loop systems. You can see my screen. First of all, I would like to say thank you very much to Giuseppe for giving that very nice introduction to the health and safety background. It's very important. Thank you also to the Royal Society of Chemistry for hosting this session this afternoon. And what I'm going to try and do now is give you an overview of closed systems in 10 slides. So a short overview, that's my mission, and I've chosen to accept it. So let's press on with this summary. The closed system, the principle is very, very simple. You have a container on the left-hand side, which you need to empty. And on the right-hand side, you have a tank that needs to be filled. This can be with a very hazardous, very nasty chemical, the kind of thing that you're in touch with every day. But you want to do it without any exposure to your operators, without any exposure to the environment of that dangerous chemical. So I know you all know the principle, but this illustrates how you would do it. A pump takes the liquid from one side to the other via a pipe. There is closed system connection to the container on the left-hand side being emptied to the tank being filled on the right-hand side. You have the option of a vapor recovery line, and all this means is that the tank that is being filled, as it is being filled, the vapors inside that leave this container and go back and are recovered into the container being emptied. So this is a full closed system with a vapor recovery line. Now you don't have to have a vapor recovery line. This is a full system. The other option is, if you can see here where the vapor is coming back in, within this coupler you can simply have an air entry system where the air from the outside world comes back into the container. That is one way of doing it. Here, this is a full system where both vapor and liquid pass from one side to the other. So it's a full system. This is how it works. You have a coupler at the top, which is attached to, this is a Mauser 200 litre container, for example. Once you press that handle down, the liquid can escape from the container. The liquid is pushed out of the container with a pump. That valve is a non-return valve, which means that liquid is not going to drip back into it. So it's a non-drip system. And once you take that coupler off, it's completely sealed again. So that liquid is not going to come out. It's only when you put it back on that the liquid leaves the container. So firstly, we'll look at the valve. The valve there at the top is shown on an IBC, and at the bottom is shown on a smaller container. It's used for all kinds of containers. It can be from anything from a 25 litre pail to a 30 litre, 250 litre, 200 litre, up to 1,000 litre IBC. In all cases, the valve has two functions. So the first one is a plug or closure. It always stays in there. From the supply from the container manufacturer at the start, it is supplied with the system. So you have the valve and a down tube underneath it, which reaches to the bottom of the container. While that plug is in there, or the valve is in there, it's like a tri-shore plug. It falls into group 1 according to the International Carriage of Dangerous Goods Regulations, or the ADR. So it is solid. It's been subject to drop tests. The liquid is not going to come out. Your employees, the outside world, the environment is protected. It fits to various threads and containers. So, 56 by 4, 2-inch BSP, all the regular container sizes are covered by the valve and threads. So on the left-hand side, you will see an IBC fitted with the system. This is a Schutz container. In fact, this is at Okema, and Mark of Okema is going to talk a little bit later in this session. He's the next speaker, I think, Giuseppe. On the right-hand side, you've just got a recap of the video there, which shows how it's attached. Perfectly closed and secure when the coupler isn't on, and the chemical is extracted by a very quick connect system when it's taken off. If you have any questions during this chat or any of these presentations, I'll be monitoring the chat. So if you want to enter them into the chat when I finish my presentation, I'd be very, very happy to answer them. So the valve, the second function is to open the liquid transfer circuit. It's like a closed circuit, and when it's opened, the liquid can escape. This is a slightly different system that you see. This is a pressure system, but the principle is exactly the same. A keyed coupler attaches to a keyed valve. This is so you don't confuse several different chemicals. In the mining industry, in this example, pressure empties the container like you would see in a pub or a restaurant. In the beer industry, in fact, the container once emptied, this is a stainless steel container which is returned and then can be refilled and reused. I'll just play that one more time so you can have a look at the principle of it. There we go. It's like serving beer, but you really wouldn't want to drink it. This just illustrates what we've just been talking about, how inert gas pressure is applied to the container. Here you see the coupler attached. The handle is down, and once the handle is down, that means the liquid can escape. When the handle is up, it means it doesn't. So a closed quick connect system to enable escape of liquids, and when it's not connected, your employees and workers are protected. We also find reference to this in the EU directives from 2016, 17 and 18. I'll just invite you to read that. So 16, 17, 18 and beyond. So it's actually mandated that for a carcinogen, a closed system should be used to protect exposure. EU sustainability studies have also shown that if you spend €1 on safety and occupational health, you will get €2 back on return. So there's a lot of science and investigation behind this. If you need any of these reports, we will be able to send them to you. Just let us know in the chat and enter your email and your company name. So the Micro-Matic closed loop system from IPI is the only closed system shown in tests to reduce the occupational exposure limits drastically below the threshold recommended. And on the last slide here, we have some of those limits. Perchloroethylene, which is very hard to say at this time of the afternoon. You can see below 1 part per million, and that's the SafeChem video that we saw, which shows how those are protected. Hydrazine hydrate, which Mark is going to talk about, below 0.02, and formaldehyde 0.03. And these are all studies which were done by our customers and clients and partners, which we can send to you and share with you. Finally, the case study from the HSE highlights this system as an example of responsible care in the chemicals industry for safely handling chemicals and protecting people. Thank you very much for your attention. Thank you again to the RSC. That's the end of my presentation.